Hi everyone, welcome. Continue with the topic of solid of revolution. Here we have a cone. And I would like to calculate the volume of the cone. Okay? Exists one formula that is going to help you to calculate the volume of the cone, but in that case I don't want to use it. I just want to applicate the integral for getting that. Okay? But however, if you want to calculate the first one to be sure that your result is going to be okay, we can do it. What is the formula to calculate the this is to calculate the volume of the cone? The formula in that case is going to be pi times the square radius times height over 3. Okay, this is the traditional form to calculate the volume of the cone. First of all, well, we need to be sure that how much are the measures of the object. In that case, we are going to talk about a cone with the radius of 2. I'm going to say that it's going to be 2, and the height that is measured from here to here. We can say that the measure is going to be, I don't know, maybe 12 centimeters. Okay, 12 centimeters and 2. Okay, the volume is going to be pi times the radius, that's going to be 2 centimeters square, times the height, that is 12 centimeters, divide over 3. Okay, so 2 by 2 in that case is 4, and 4 times 12 is going to be 48, and this is going to divide over 3 is going to be 16. We're going to have 16 pi cubic centimeters, and this is going to be the volume of the cone. But this is done by the traditional formula. I don't want to do it by that. I want to do it by solid of revolution and with the integral calculus tool. First of all, I need to write over here where is the axis of revolution. This is the axis of revolution, and it's my decision if you want to keep the axis of revolution in y-axis or x-axis. Traditionally, it's more common that we use the x-axis to make some calculus and to use the formulas over here. But let me tell you something. It is the same at the end of the day. It's the same, but some mathematical informatic tools that I'm gonna use later, some programs are just available to take as a revolution axis x. So that's why I think it's better that we continue with this one with x and f for x. Okay, but it's the same. Okay, so for example, here you can say that this is going to be the base and this is going to be the top of the cone, or vice versa. You can say that this is going to be the top and this is going to be the base. Whatever, okay, is your decision. Okay, in that case, I'm going to decide that this part is going to be the top, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and here is going to be the base. Okay, this is going to be my decision, and I'm going to explain why later, because it's easier if you take that decision. Here, as you can see, we have a radius of 2, so I'm going to write over here 1 and 2. Okay, and then I'm going just to write this little part that is going to be this one. Okay, this part of the cone, right? Remember that what are you gonna do? You need to make here a differential rectangle that according with the axis of revolution, it's going to become what? In a differential disk. Okay, Okay, so it means that here we are going to use the method of the disk. Okay, good. So the method of the disk. Remember that the formula of the method of the disk is going to be volume. It's equal to pi of the integral from a to b of some function squared that is represented by the radius times dx. Okay, and the question is, what is the radius, or what is that function? That function is this one. This function in that case is not a constant. This function is going to be a linear function, and everybody knows that the linear function format or form is this one. Okay, so first of all we need to calculate, we need to estimate what is this function in the linear. Okay, look at this. The first reason that I decide to start here with the top and here with the bottom of the cone is because here the line is going to cross by the origin of the Cartesian plane. And remember that B is the intersection with the y-axis. In that case, B is going to be 0 because the intersection is going to be 0. So I have one part of that equation. If I decide instead to do like this, to do like that one, the intersection will be on number 2, and this is going to be plus 2. But it's better to reduce it, so that's why I decide to start over here. Okay, so in that case, B has an intersection of y-axis is 0, so B is going to be 0. So the only thing that I need to calculate is the slope. And remember, just remember, note, it's very easy to calculate the slope. Is the here is the division between the increment of y over increment of x. In that case, it's going to be positive, okay, because it's ascendant, the line. In the case that we have descendant line, is going to be negative, but it's going to be positive. Now let's count. How much do we have over here? 1, 2. We have 2 units on y. And how many units do you have on x? You have 12 units. In that case, it means that it's going to be 1/6, and this is the slope. Okay, so it means that this one, this function, is going to be just 1/6 of x. Okay, well, I have everything to start to work with the formula of the method of the disk, and then I'm gonna say the volume it's equal to pi of the integral from, we start on 0 and we finish where? Okay, let's make over here the solid of revolution. There we go. Okay, we're going to start on 0, we're going to finish on 12. Good. Of the function, what is the function? The function is 1/6 of x squared dx. Good. First of all, let's start with the constant. 1/6 squared is 1 over 36, and I'm going to put it over here, pi over 36, okay, outside of the integral from 0 to 12 x squared dx. Now the integral is going to be available to develop. Here I'm going to write pi over 36 times x cubic over 3, and this is going to be evaluated from 0 to 12. Right now we're going to multiply 36 times 3, and this is going to be pi over 108 x cubic from 0 to 12. Okay, and first of all we start to evaluate it on 12, and this is going to be pi times 12 cubic over 108 minus pi times 0 cubic over 108. Obviously this is going to be 0, and just the the final result is going to be, let's use our calculator to develop that operation. We're going to say 12 cubic is going to be 1,000. There we go, 1,728 over 108, and this is going to be 16 pi cubic centimeters. Yeah, look at this. We had exactly the same result that with the traditional formula, but here we are using the integral calculus as a mathematical tool to calculate the volume of that figure through the method of the disk. Right now I'm going to explain the same example that we developed on the worksheet about the cone, but right now it's going to be with a program, computer program. This program is called WinPlot, and I'm going to explain how to do it. Okay, first of all, I'm going to click here in Window in 2 dimensions. As you can see, we got a Cartesian plane. Okay, we have different options over here about the appearance. For example, here in C, we can go to this option, and then we can select the rectangular appearance, and here it's if you want to have the intersection of each point, well, it's decision of you the appearance that you want to work with. Okay, remember that we decide that the function that is form the cone is going to be 1/6 of x. In that case, I'm going to select the equation here, and then go to explicit, and here you got f or x equal to, and I'm going to write 1/6, or instead 1/6 I'm going to write x over 6. Okay, and I'm going to select OK. As you can see, maybe if you want to appreciate better the line, just right over here again, push, give a double click, and here you can see the thickness of the draw. Maybe it could be 3, and it's better, you can see it better. But how to edit this function, because I want to cut, because I just want to have from 0 to 12. Okay, in that case, if you want to edit or you want to do whatever thing in the function that you already have, just go to equation, and here you are going to have inventory. Here you can back to the function and make a lot of addition. In that case, I'm just gonna click again, and here we have the to block the interval option. I'm going to select that one, and I'm going to say, okay, I want to start on 0 and finish on 12. Okay, and I click in OK, and as you can see, I'm just gonna have the little piece of the function that I need. In that case, it's from 0 to 12. Okay, first of all, I need to be clear with this. The WinPlot program is working only with the method of the rings, not with the method of the disk. So in that case, I'm going to need instead one function, two function, but in that case, this is not a problem of the method of the rings. So in that case, I'm not going to use another function that's going to modify my cone. The only thing that I'm going to do is to add a function that in that case is going to be f or x equal to 0, and then I'm going to press OK, and the other function is going to be the axis. Okay, so I'm going to work with the axis and the function. So in that case, we are not going to have a problem. Okay, we are going to have exactly the same result that we already calculate. Okay, here we have two options. Here said 1 and here we got 2. If I select 1, you can see it a revolution surface. Okay, in that case you are going to form the revolution solid that you want to work with. So the thing that I'm gonna do is just to select surface revolution surface, and here we're going to have the revolution that you want, or the function that you want to make a revolution with. In that case is the first one, this one, around the axis of what? Of x. So I need to select this one, and it said the start of the arc is going to be in 0 and the finish of the arc is going to be where? In 12. Okay, from 0 to 12, and then I want to see to see the surface, giving a click over here, and as you can see, this is the surface that we form with the revolution. Okay, very good. So look at this. How can I move it? Just with the arrows that you have on the keyboard, you can push it and then you can move it. This one. Okay, this is for one way. I'm gonna close over here. I'm gonna put it over here, this one, and I can close this one. Okay, and right now the thing that I want interesting on is to calculate the volume of that solid revolution. That's why I'm going to go to 2. So that's why I'm telling you that I'm just going to, well, the program is just going to work with the methods of the rings. Here we have integral of volume. In that case, it's not integral, it's volume, because this one is for areas. Okay, this one is for volumes. Okay, I'm going to press here volumes, and here I need to put it the upper function and the other function that we have here over here. This is going to be like a f for x and g of x. This one is the upper one that is over here, and the other one is y. The only thing that you need to put it over here is it's going to be from 0 to 12, and the subdivisions in that case is going to be a 1000. Subdivision means that I'm going to estimate the volume with 10 representative sorry, 10 no sorry, with 1000 representative cylinders. Okay, the cylinder that we talk about, the differential cylinders. Here I'm going to press volume, and then I have 50.26, and remember that the result that we got over there was 16 pi, and 16 pi it's 15.26 54 82 46. Okay, so as you can see here, we got exactly the same result, and this is the procedure. You want to use WinPlot just for make the solid of revolution, and or if you want to calculate the volume of that solid, so with this program you can do it. And even if you have a homework or something and you want to do it in a Word document, for example this one in a Word document, so the only thing that you need to do is just to go to equation, here, and just copy, put it in your inform, maybe here you can copy, and then you automatically we have the image. Okay, and then this part, the other part that you have over here, so you can copy even, well, now you need to press the screen to make a screenshot and put it over here, and then you will have ready the report of the homework, in the case that you have to use a computer program to be part of the some exercises of calculus of solid or revolution.